say that these are two cells with EMF and internal resistance as shown in figure. Now, in parallel, there is really no need of helping or opposing, because we make much thing. Okay, so this is what we have got. Alright? Diagram clear? Two cells are in parallel. Current may not be same. Yes, parallel में same जो है. Voltage is same, but current may not be same. Another thing. Suppose this point is A and this point is B. Now, if I put draw equivalent, then as usual, equivalent cell is only one, right? And it has epsilon equivalent and R equivalent. And once again, the points here are A and B. Now, we use Kirchhoff law at this junction. So I1 comes here, I2 comes here. Then how much current should go here? I, which is equal to I1 plus I2. This I will be equal to I1 plus I2. Is that okay? That we are calling I for the time being. Okay, now we have to okay. So this is I. Fine. All diagrams clear? Now, calculate. We have done this earlier. Abhi kahin hum go parallel में same तो voltage, correct or not? So terminal voltage of cell 1 is V1, which is same as V, isn't it? बदल में same हो जाता है ना? Is going to be how much? Epsilon 1 minus I1 R1. Understood? Yes or no? Sure. From this, I can say that I1 is equal to epsilon 1 minus V upon R1. Okay, then half that. Is it clear? Sure. Epsilon 1 minus V upon R1. This you can further split the numerator and write it like this. Is that fine? Fine or not? Yes. Sure. Clear? Now, this is equation 1. The resistance is in parallel में I equal to I1 plus I2. But I value मूकवानी, I1 value मूकवानी, I2 value. Do you remember that? Yes. Let's do it here. So, similarly, I2. अभी मैं लॉगिन नहीं तो मैं जाते कर लो. I2 equal to epsilon 2 upon R2 minus V upon R2. All this equation 2. बच्चे step લખો હોય. You are free. Okay. અને હવે for equivalent circuit. For equivalent cell, we will get V equal to epsilon equivalent minus I into R equivalent. Is it clear? So mi આની જેમ શું આવે? Therefore I is equal to epsilon equivalent by R equivalent minus V into 1 by R equivalent. એટલે V upon R equivalent to be very clear. If થાય ને V upon R equivalent is same as V into 1 by R. ખાલી આમ અલગ કરીને રાઈટ. Is it fine? Fine or not? Sure. So call this equation 6. Now come to this junction. Okay. Using Kirchhoff current rule. What do we get? I is equal to I1 plus I2. Understood? I is equal to I1 plus I2. Sure? What that? હવે આ બધી વેલ્યુઝ મૂકી દો. Using 1, 2 and 3. Okay. I ની જગ્યાએ શું લખવાનું? Epsilon equivalent upon R equivalent minus V into 1 upon R equivalent is equal to right hand में out there epsilon 1 by R1 minus V by R1 plus epsilon 2 by R2 minus V by R2. Everything clear? Any value I will write. Okay. Now what I do is on the right hand side, I will collect terms. With V together. Did you get that? I've collected terms with V together. समझाओ कि नहीं? Right hand में do here and here minus V is common. What's left behind? 1 by R1 plus 1 by R2. समझ पड़ी क्या नहीं? Okay. So now we are ready to compare both the that is right on the sides. लगे तुमने what's what? एकदम easy से ये पहला पकड़ो. 1 by R equivalent is 1 by R1 plus 1 by R2. Yes or no? Sure. Can of very by comparing LHS and RHS. One by R equivalent is equal to 1 by R1 plus 1 by R2. A second term comparison thing. What about first term now? So whatever is remaining here, that should be this bracket, correct or not? So epsilon equivalent upon R equivalent is equal to epsilon 1 by R1 plus epsilon 2 by R2. So these are the two relations for cells in parallel. Okay, these are the two relations for the cells in parallel. Is this first one at all surprising? नहीं नहीं. When two resistances are in parallel, so it equivalent कैसे है? 1 by R1 equal plus 1 by R2 equal, that gives you 1 by R equivalent. Understood? कहाँ तो कहीं तुमने याद रखने की जरूरत है. This one. Do not try to take LCM and do anything extraordinary. This is the simplest form. Let me tell you that this is the simplest form. तो मैं बीजों का ही फॉर्म करवा जाता हूँ तो आनंदी तो वो है complicated है, right? Okay, but yeah, this is a prerequisite to this. इन्हें आ नहीं करो तो आ नहीं कर. Why? Because there is R equivalent. Without that, you will not be able to get. Clear? What I am saying is clear to you? What if one of the cells was opposite? What if one of the cells was opposite? तो क्या change करोगे? What do you suggest? आमा के change करोगे? Unwanted things never get subtracted. याद है? बराबर के नहीं? So there will be no subtraction here. आमा तो plus हो जाती है. तो आमा minus आते. क्या minus आते? If suppose epsilon 2 is the other way around, तो ये मैं ये remove कर सकता हूँ. Is it okay? Sure. What if there are more than 2? आमा तो कोई problem नहीं है. आमा और है ना? Epsilon by R is equal to epsilon by R, epsilon by R. ये add करता है John. If there are more. Got it? Sure. Yes. Fine. Shall I erase everything over here? So let's solve one question of cells in parallel very quickly. So suppose this is a 4 volt and 2 ohm cell. And this is 8 volt and 2 ohm. And this is a resistor, and say this is 4 ohm. Now we want to find out how much is the current through each cell and each resistor capital R. Question is clear? We're taking all of this now. What to do first of all? You can solve this question by Kirchhoff's law, by the way, if you want to do that. Okay, આરામથી થઈ જાય ને. અહીંયા I1 I2 I1 plus I2 ટૂંક લઈ લો બે લો ફક્ત નાખો. You will get the answer. Method clear? પણ એ રીતે આપણે કરવાની જરૂર નથી. You can do it by parallel idea. These two cells are in parallel. So પહેલા એનું R equivalent. What will be small R equivalent? Hurry up, come on. How much will be small R equivalent? 2 and 2 in parallel, 1 ohm. Is that clear? So now epsilon equivalent find for fataphot using the formula. Find out epsilon equivalent.
6 volt. 6 volt.
Epsilon by 1 equal to 4 by 2 plus 8 by 2. So that is 2 plus 4. Yes. Epsilon equivalent is equal to 6. Is that clear? Okay. Abhi average ave? No. There is no such rule. It is a coincidence. Abhi 2 2 છે ને એટલે એવું થાય. Okay. It could have been anything else. Okay. So epsilon equivalent is equal. Now we draw a new circuit. This is the equivalent circuit. 6 volt and 1 ohm. And this is a resistor. How much? 4 ohm resistor. So now I will solve. Done. How much is the current? 6 by 5 ampere. Is it okay? કયો current છે? કયા cell માં current? Cell માં? This is current in the cell. So this is the current in the 4 ohm resistor. ये है ना I value is going to be 6 by 5. Okay? Fine, that is clear. Let's proceed. હવે શું કરવાનું? Find current in this and this. કેવી કરશો? हाँ?
B equal to epsilon minus.
B equal to epsilon minus I up. B ની value same but કેટલી? B ની value 6 volt. Is V terminal voltage or EMF? V is terminal voltage, not EMF. भूल गया symbols. V is terminal voltage, it's not EMF. So terminal voltage cover. Is EMF same in parallel? Is EMF same in parallel? Yes or no? Is EMF same in parallel? Yes or no? Is terminal voltage same in parallel? That's right. Terminal voltage is same in parallel. EMF is not same. આ બેનો same છે. તો પછી બરાબર ને? તો શું કરવાનું હોય? Find terminal voltage first if you want to go by that. તો આનો terminal voltage લો. આનો terminal voltage કેટલો? What's the terminal voltage? Hurry up. 24 by 5. अरे terminal voltage the formula I into capital R नो करना. Yes or no? Do you remember this formula of terminal voltage? This है one is epsilon minus I and the second one is I into capital R. Correct or not?
Yes.
So I into R 24 by 5 ampere. Understood? Sorry, volt. 24 by 5 volt. Clear? We got terminal voltage. Our terminal voltage કોનો છે? આનો છે, આનો છે કે આનો છે? All same. તો હવે આનો terminal voltage મળી ગયો ને. તો એમાં I1 કરંટ ફ્લો કરો અને Never mind. Hurry up. Done.
I1 negative.
Negative, possible, unless you have made a mistake. Possible. Negative no meaning to that. The current is in opposite direction to what we are assuming. Okay, I1 can. Okay, let's see. V1, which is same as V, and that is going to be epsilon 1 minus I1 R1. Is this clear? Clear or not clear, everyone? Okay, let's put value. So V is 24 by 5. Epsilon 1 is there. Value મૂકી નથી આપતા શું તમને લોકો epsilon 1 is 4 minus I1. We don't know. R1 2. So that's why I1 into 2 is equal to 4 minus 24 by 5. You got it? 4 minus 24 by 5. So this is going to be minus 4 by 5, and that's why I1 is minus 2 by 5. Is that okay? Minus 2 by 5. How got it? Nothing else to. Is this clear?
Yes.
Sure. Okay. પછી બીજું શું I2
8 by 5.
have you found it similarly?
Yes. I by 5.
Take an answer.
8 by 5.
Let's do it by terminal voltage. Okay. Just for confirming that everything is okay. Chalo, okay, second one V equal to epsilon 2 minus I2 R2. Therefore 24 by 5 is equal to epsilon 2. How much is epsilon 2? 8 I2 into R2. So પછી અમારી સ્પીડે કરો. So I2 is equal to
8 by
8 minus 24 by 5, and then by 2, so 40 or 62. Yeah, I2 is equal to 8 by 5 ampere. Then add karo.
6
So
by
6 by 5 આવે છે. That means everything is fine. Is it clear? Okay, so these are the currents. So basically what's happening is as follows. This is a fairly larger battery compared to that. So it will pass 8 by 5 ampere current. It will go till this point. Now 2 by 5 ampere current will flow this way, and 6 by 5 ampere current will flow this way. Did you understand? Our battery might actually current ઊંધો જાય. Did you get it? Yes or no? So that is what is going on here. Okay. So again, current directions are irrelevant. Do you see that? Current directions are irrelevant. ઊંધો હોય તો automatically negative આવી જાય. There is no need to worry about that. Fine. This is a hallmark scalar behavior, isn't it? Think about it. Temperature ઓછું હોય તો automatically delta T negative આવી જાય કે નહીં? Why? Because temperature is a scalar, and change in temperature is also a scalar. Sounds pretty? You're not so much pretty. Force માં એવું ન થાય. Suppose I am applying a force towards the right side. If I decrease the force, less, so zero થાય. Is there a force possible which is less than 0? You know that, or so that's because force is a vector, right? Negative ma force is less than 0 no that. I hope you get that. Nevertheless, okay, so this is what we have got over here. Our some same point of the To be very frank, I don't like this method. આ બધું નો કરે એટલે આગળ જ્યાં બધું એના બદલે કિર્ચોફ રૂલ યુઝ કરે. How so? We assume that current is I1 here. Now here start so we'll take a look. Okay, so પહેલા એની પાસ થવાનું. What the current? We have already found the current. Yes or no? 6/5 અહીંયા સુધી તો પહોંચી ગયા બરાબર. Is it clear? તો શું થાય? -6/5 into 4. Got it? પછી આમ જવાનું યાર. અને I1 આમ અઝ્યુમ કર્યું ને. So we are going in direction of current. એટલે -I1R. R1 શું છે? 2 અને પ્લસ 4 is equal to 0. એટલે એક જ સ્ટેપમાં બધું થઈ જાય ને વોલ્ટેજ ટર્મિનલ વોલ્ટેજ ફાઇન્ડ કરવાનું. આમાં એક બાજુ તમે એપ્સિલોન માઈનસ IR થી કરો તો હજી લાંબુ થાય. You get what I'm saying? Right? But if you just use Kirchhoff rule, એક માં પૂરું આ સ્ટેપ સોલ્વ કરો એટલે આન્સર આવે. Understood the method? Right? Okay. Let's go on to the next. Okay. Now we still have a potentiometer question remaining to be solved. बाकी देखिए करना क्या पूरा. Example. The example 6 that is remaining, we'll do it at the extreme end of this chapter. There is the symmetry method according. Okay. So example 10. Resistance of R ohm draws current from a potentiometer. Potentiometer has a total resistance R0 ohm. Actually, I suggest that in the second line we write potentiometer wire. The potentiometer wire has a total resistance R0 as shown in figure. The voltage V is supplied to the potentiometer. Derive an expression for the voltage across capital R when the sliding contact is in the middle of the potentiometer wire. Okay. Now there is so much to understand over here. I can draw here pehla 3.10 છે ને example. See. If you have got some wire, long wire which has some resistance, એટલે હું એને આવી રીતે draw કરું. We could have just drawn it straight also, no worries there. Now we have the sliding contact somewhere. So suppose we are making it touch over here. The whole thing has resistance R0. Then do you realize that this sliding contact up to this point, it actually divides this wire into two parts. From here to here and from here to here. So like let's say that this has resistance R1 and this has resistance R2. Then always R1 plus R2 will be equal to R0. Is that fine or not fine? Total wire has how much resistance R0. So કોઈ પણ બે પાર્ટ લો જેમાં આમ right side slide કરશો, which will increase? R1 will increase and R2 will decrease, but the total will always remain same. Understood that? As this slides to the right side, R1 will increase, R2 will decrease. Total always remains R0. Fine. Now let's read the question again. So this is potentiometer wire. It has how much resistance? R0 total. And for simplicity, I am drawing it like this so that we can understand what's in the circuit. What's a gap करने को जरा. Just for our purpose. आपको continuous है. So here is the jockey, correct? In the middle. So what will be R1? The question again. This jockey is exactly in the middle. So what will be R1?
R0 by 2.
R0 by 2. Raise your hand if you understood that. Why so? Half length. So half the resistance. Correct or not? And what is R2?
R0 by 2.
Yes, very. Is this clear? Now what is connected with this jockey here? A resistance R. Okay. And then over here a V volt supply is given. Okay?
Yes.
Okay, so this is V volt. Up to R0. This is the circuit diagram. Circuit diagram is clear. And a potentiometer has a relationship. Look at the way I have drawn the circuit. It's only that we are sliding it on the wire. But once you put it this way, this looks like a typical series parallel circuit, doesn't it? Battery is there, some resistances are there. We find the current.
They have an expression for the voltage.
We have to find the expression for voltage across આવા શબ્દ પેલા કર્યા બેટરી હોય ને થોડા રેઝિસ્ટર હોય આનો વોલ્ટેજ ફાઇન્ડ કરવાનો ઓલાનો ફાઇન્ડ કરવાનો આનો પાવર ફાઇન્ડ કરવાનો આનો કરંટ ફાઇન્ડ કરવાનો યાદ આવે છે તો આ સમ actually potentiometer નો છે. Do you understand what I am saying? Once you understand this circuit, that's it. હવે આને કઈ potentiometer નું કઈ રિલેશન just do it normal. Let's begin. I mean the circuit you want to find some voltage, you have to simplify it. Yes or no? Okay, they're going to simplify something in series parallel. What is in series or what is in parallel? R1 and R2 are in series. મજાક કરું છું. નો મજા આવે ને R1 R2 are in series? No. અહીંયા બ્રાન્ચ નથી? છે ને? તો પછી કે છે series. તો R1 and R are in parallel. Okay? Sure? Yes. So in equivalent R dash, suppose. To be very frank, this is an exercise in algebra, nothing else. તમને divide, multiply, symbols સાથે કરતા આવડે છે કે નહીં એનો જ question છે. This is fine. હવે આગળ કઈ થાય? What? These two are in series. So simplify કરો એટલે R equivalent આવી જશે ને V અને R equivalent. So current will be flowing I here. Current will be flowing I here. I is same as current આવે ને? Yes or no? Yes. Now what's the aim? We want to find the voltage for R. Here I am making a simple plan application. આનો voltage find કરવાનો. આ કેમ છે? Series parallel. પહેલા શું મળે? Voltage પહેલા મળી જાય. Do you realize if you go by standard method then so પહેલા voltage મળી જશે. Is that clear? So first of all we will be able to find VR. VR means voltage for R. Okay. But that voltage for R will be same as voltage for R1. એનું આપણે ક્યાં કામ? This will be same as voltage for R dash. Yes or no? Yes. Sure? Why so? In parallel all the voltage is the same. આનો ને આનો same જ હોય ને? Okay? Sure? અચ્છા હવે પણ આના માટે તો પહેલા વોલ્ટેજ ન મળે ને કેમ? Because these two are in series. એના માટે પહેલા શું find કરવાનું? Current. So first we'll have to find I. Plan is clear? Okay? તો કરના કેમ ફટાફટ ઊંધેથી ચાલુ થશે. પહેલા I find out પડશે. So physics is just like this. જ્યારે તમને આવડે નહીં તો ઊંધેથી વિચારવાનું કે આના માટે શું find out પડે, આના માટે શું find out પડે, etc. Right? Let's start. So first of all R dash ની વેલ્યુ ને બધું સિમ્પ્લિફાઈ કરીને લખવું પડશે. R and R1 are in parallel. આવડે છે? Therefore R dash is equal to શું આવશે? લખો જલ્દી કરો. R dash ની વેલ્યુ ફાઇન્ડ કરો. હરી અપ. Pencil થી diagram no draw કરો. When I am waiting for you to find R dash, હજી મોટા ભાગના લોકો diagrams જ draw કરે છે. એમાં કેવી રીતે મેળ પડે? Your entire focus will be on drawing and not on solving.
R not R upon.
R dash.
R not R upon.
R0 by 2 into R upon R plus R0 by 2. Yes or no? Clear or not clear?
Yes.
Sure?
Yes.
Everyone got that? Now the short cut then R1 R2 upon R1 plus R2. So this is equal to સિમ્પ્લિફાઈ કરી શકો છો આવે r0 r upon 2r plus r0. Okay, very good. r dash થઈ ગયો. હવે r equivalent એટલે r dash and r2 are in series. Therefore r equivalent is equal to r0 r upon 2r plus r0 plus r0 by 2. બરાબર એડિશન જોજો આનો. एग्जाम में पेंसिल थी करजो बट क्लासरूम में તમે પેન્સિલ થી કરવા માટે ટાઈમ સ્પેન્ડ કરશો તો આપણે સોલ્વ થઈ જશે. Take it common. If something is common, take it common. You what okay, so first of all we will get 2r0r plus 2r0r plus r0 square એવું જાય ને upon 2 into 2r plus r0. Okay, so this is going to be 4. 4 isn't it? And then r0 is common. So 4r plus r0 upon 2 into 2r plus r0. Is this fine? क्या होना था तो? होना था तो चेक करी जो. मिस्टेक करी तो कौन बने? Right, so this is R equivalent. Now once we have found R equivalent, we'll go over to the next thing. R equivalent now current hour find करता है. Current hour से hour से करो जल्दी. मैंने तो किधर this is going to be an exercise in algebra. कहीं है नहीं हमारा. Number नहीं है पर इधर हमने तो मैं करने को. Left ઉડાડજો છૂટથી જેટલું તમે ઉડાડી શકો. It's a long one. કેટલું બધું કરવાનું છે હજી તો. થઈ ગયું? હા, હવે વોલ્ટેજ ફોર R10. ઓકે તમે લાઈટ ઓછી નથી પડતી અહીંયા? ચાલુ નથી થતી? આ લાઈટ એની ये हमारे क्या क्या पेंसिल से लगे એટલો બધો ટાઈમ છે ને તો હોમવર્ક આપવું પડશે એક્સ્ટ્રા. થઈ ગયું પ્રિયા? આવી ગયો આન્સર? ચેક કરી લે પાછો. એક્ઝામ્પલ આન્સર જોઈ તો તારે આવી ગયો તો તું શું કામ જોઈ? તારે નથી જોવાનો, પ્રિયાંશને જોવાનો. આ સ્ટેપ ઊંધા ઊંધા કરો. આઈ આવી ગયો કે નહીં? યસ ઓર નો? હુ ગોટ ઇટ? હુ ગોટ આઈ? ઓકે, રાઈટ. Rohan, what's your answer? V into 2 times 2r plus r0 upon r0 into 4r plus r0. Okay, this is fine. अरे कहीं नहीं ना आपने उल्लू बाय मल्टीप्लाई कर देना है. V equal to I r और I equal to V by r. Okay, Sure. So this is the current in the circuit. Current in the circuit. Okay, this is I. So we can write therefore voltage across R dash is V dash equal to IR dash. So what is I? This is I. 2V 2R plus R0 upon R0 into 4R plus R0 into R dash. Sorry, मैं पहले R dash रखने. I'm so sorry. बराबर है.
हाँ सर, अब R dash.
अब बराबर है. क्या I है ना? अब R dash लगा. So R dash is R0.
सर ये R equal R0 ऊपर.
R dash is R0 R upon 2R plus R0. Is this clear?
Yes.
Values साथ ही लग दो. R dash. This is R dash. Fine. Okay, anything cancelled?
R0.
R0 cancelled.
2R plus
And
R0.
this whole bracket is cancelled. Careful is not taken. 2VR upon 4R plus R0. This is V dash. But if we have found V dash means the voltage for this, that automatically means we have found this because those two vary parallel.
Yes.
Okay. So last step.
VR.
What do we get?
V.
The voltage across R is VR, which is equal to V dash. Okay, that is equal to 2VR upon 4R plus R. Just imagine this question if all numbers would have been given. So question now form was over. Alright, now that's it for this particular question. Now I want to go over to instruments. Instruments, that is things that we use to measure. We have already studied about two instruments. Which two? One, which the meter bridge. Second one, potentiometer, right? Okay, and while we were doing all that, we have also understood a little bit about galvanometer, like not much, of course. Now, what I am going to start teaching right now is actually given in your textbook in chapter 4, and that also at the end. Right? Chapter 4 remember that. But this topic, in my view, is more suited here, especially when we want to solve general equations. So first of all, we are going to talk about ammeter. Have you heard this name earlier?
Yes.
Ammeter is used to measure current. Look enough. Measures current. Okay. Now let's start with a theoretical problem. Suppose here is a 10 volt battery without internal resistance. Suppose we take ideal. And this is a 10 ohm resistor. How much current will flow in that 10 ohm resistor? I am interested in knowing how much is the current here. Can you help me? Yes or no?
Yes.
So what will be the current? 1 ampere. You measured it? You measured it? You calculated. Is this fine? So what you did is theoretical. Fine. Sure. So measure करना है तो शुरू करो पड़े ammeter connect करो. So if you want to measure how much current is flowing in this resistor, do you realize that I would have to connect an ammeter in the series with it, in the series connect? क्या हो चुका? Because whatever current is flowing here, that same current will flow through ammeter. Then it will be able to measure that current. आपने आनो current measure नहीं करना, आपने आनो current measure. But to measure this current, you have to connect it here. What if you connect it in parallel by mistake? Then it will be actually measuring something else. Is that okay? It will be measuring something else. It's like you want to measure mass of a person, but that person is standing next to the weighing scale. અને weighing scale પર કોક બીજું જ ઊભું છે. Right? It's exactly that situation. So, simple rule, ammeter should always be connected in what? Series. Looking up. ખબર જ હશે કે 10th માં કીધું હતું. Ammeter is always connected in series. એટલે parallel માં લગાડો તો blast ન થાય. Remember that. But it becomes useless. Then it will not be able to measure the current. It might measure some other current. Okay. It won't measure current in this way.
સર આ એમીટર આગળ લગાડી તો રજિસ્ટર ની આવે.
So suppose there are 4 ammeters. 1, 2, 3 and 4. Okay, given that they are all identical. So bada measurement same है. Is that clear? Because everything is in series. In series what will be same?
Current.
Understood? So because current will be same, it doesn't really matter whether you connect it front or back. Right? So એટલે જ હું તમને કહું કે તમારે બધા છે ને ક્વેશ્ચન પૂછો એનાથી મને છે ને તમને સમજાવવાનું મન થાય નહીતર એમને એમ કહું કે હું ઘણું હજી મને ખબર હોય બટ એવરીથિંગ ડઝન્ટ કમ આઉટ ઓન ઇટ્સ ઓન કારણ કે ગોખેલું નથી ઇન્ટરેક્શન થાય ને તો જ યાદ આવે કે હા જો આવું આવું કંઈક હોય ને ત્યારે આવું કરવું પડે રાઈટ anyway so you can connect it here or there either way no problems whatsoever suppose this is 10 ohm and this is 10 ohm. Now when you connect an ammeter like this, everything always has some resistance, yes or no? Cell nahi resistance hoy. The ammeter nahi de hoy because ultimately inside the ammeter there will be wire, current will be flowing through it. So I am making resistance. Suppose that resistance is R. Then how much will be the current in this circuit now? Suppose this resistance is R. How much will be the current in this circuit? Find for R current I in value so. It will be 10 upon 10 plus R. Is that clear? Yes or no?
Yes.
Sure. 1 ampere आयु के no आयु? Is this 1 ampere or not 1 ampere? Not 1 ampere. So theoretically calculate करता था त्यारे 1 ampere. और लगाड़ा मैंने measure करे तो then circuit has changed. Nature is fooling us. એવું થયું ને? એ નોંધ્યું? ખબર પડી શું એમને એમ તમે કેલ્ક્યુલેટ કરશો તો 1 ampere very good but if you try to measure it it's not 1 ampere there is an error તો આવે suppose this resistance of this ammeter is 90 ohm suppose it is 90 ohm so that do you see something funny શું આવશે only 90% error only 90% error આનો સીધો જ મીનિંગ એવો છે if you want to reduce error the value of R should be less કેમ સિરીઝ માં લગાડો ને એટલે આ રેઝિસ્ટન્સ ચેન્જ થઈ જાય so current will also change theoretically આન્સર 1 ampere આવે પણ practically measure કરવા જાવ તો 1 ampere આવે જ નહીં so that brings us to this sentence ideal ammeter you can avoid the of course ideal ammeter has zero resistance समझ पड़ी कि 0 हो जाए suppose this R is 0 so error is not did you get that if the value of R is 0 then there would be no error whatsoever but એવું તો હોય is it possible to have ammeter with zero resistance yes or no yes or no no that's right તમને વીક બહુ લાગે પાછું મારા ક્વેશ્ચન માં આન્સર you can't make anything with zero resistance but we can definitely have this sentence that good ammeters the good करता है but just one for less error in measurement, resistance of ammeter should be, what do you think, as large as possible or as small as possible?
As small as possible.
Should be as small as possible. Ideally, it will be 0. Okay? So now we will stop here. Next time we will discuss what can we do to make the resistance less. અત્યાર સુધી તો આપણે એવું કહે છે ને કે unwanted things can never be removed. બરાબર ને? But there is still a way to manage it. Okay, turn off.